The function f of x equals 1/9 times the quantity x minus 7 whole squared plus 3 gives a metal ball's height above the ground. F of x in inches, x seconds after it started moving on the track, where x is greater than or equal to 0 and less than or equal to 10. Which of the following is the best interpretation of the vertex of the graph of y equals f of x in the xy plane? So we have this function here, f of x, that gives us the height of the ball above the ground as a function of x, the number of seconds after it has started moving on a track. So we can graph this function in our graphing utility, and it will look like this parabola. So we graph the function of y equals f of x as a function of x, this number of seconds. So the x-axis will tell us how many seconds have passed, and the y-axis tells us the height of the ball. And from the problem statement, it tells us that x is only valid between 0 and 10. So we're only going to care about the parts of the graph between x values of 0 and 10. So this means at an x value of 0, the function here has a y value of 10, or this y value right here. So the ball starts with this certain height, and we can see from the parabola that this height starts decreasing as x increases. So it's initially a decreasing function. And the height here decreases until we get to the vertex. So at x equals 7 seconds, we reach this vertex here. And here the height is 3. And after 7 seconds, the function's height here starts increasing again, which means that at the vertex here, we reach the minimum height of 3. So after 7 seconds of the ball rolling on this track, we reach the vertex, which we can see from this parabola here that it's the minimum height of the function. So after 7 seconds of rolling, the ball reaches its minimum height at the vertex. So we can use that to answer the question of how to interpret the vertex. So after 7 seconds, the ball reaches its minimum height at the vertex, which is what answer choice A says here, that the ball's minimum height was 3 inches above the ground.